Welcome back. Still talking about the quadratic formula. So here we go. We're going to have any quadratic, and it's going to be set equal to 0. I can use the quadratic formula to be able to solve for the values of x that will make left hand and right hand side equal 0. Remember, it's plus and minus, but that just represents two cases. So this is what I'm working with. And there's two cases. There's going to be case 1, where it's minus b plus b squared minus 4ac over 2a. And we're going to have x equals minus b subtract b squared minus 4ac over 2a. Now, what's interesting here is this value. That value is called the discriminant. Discriminant. And it's equal to that. B squared minus 4ac. Which means that if I talk about the discriminant, I'm talking about the value underneath the square root sign. And we're going to talk about this a bit. And the discriminant has three possible cases. Case 1, the discriminant can be greater than 0. Case 2, the discriminant can equal 0. And case 3, the discriminant can be less than 0, negative. So negative, positive, neither positive nor negative, but 0. So those are your three cases for the discriminant, and we're going to use the discriminant to tell us about the nature of the roots. So what happens is, if I have the discriminant is greater than 0, I'm going to have x equals minus b plus or minus a number greater than 0 over 2a. This is going to give me two distinct roots, two distinct x-intercepts. One of them is going to be the negative b minus square root number over 2a, and the other one will be the negative b plus square root number under 2a. So we're going to have two distinct, which means different. So you could say different if you don't want to say distinct. Real, that talks about the type of number they are. They're a real number. Real roots. And that's going to be two x-intercepts. So that's your first case. Case 2, however, if b squared minus 4ac is actually equal to 0, well, that would give us x equals negative b plus or minus square root of 0 over 2a. Square root of 0 is 0. So that'd be negative b plus or minus 0 over 2a, which is negative b over 2a. You will notice that there's only one answer here. That means that when we go to look at the roots, there's only going to be one value. What we actually say is that there's two equal roots, and I'll show you why that is when we do an example, why it's considered two equal roots. But there's only, and we say two equal real roots, two equal real roots. But there's only one x-intercept, and that is wherever the negative b over 2a was. Our third example is going to be if the discriminant is negative. What that gives us is x equals negative b plus or minus square root a negative under the square root sign, a negative number. Well, you've been told by your grade 10 teachers that you can't do that. You can't have the square root of -3. You can't have the square root of -8. Your calculator will tell you error. It can't be done. There is no way of getting a negative under a square root and having it make sense to a graph. So what we say now is that since there's no such thing as a negative under a square root to make sense of a graph, we say that there are no x-intercepts, meaning that our quadratic would look something like this in this case. It's not going to touch the x-axis at all. So there's no x-intercepts, and we actually say, well, you can say two things. You can either say no real roots, and I'm happy with that, or you can say two complex roots. And that just means that these numbers with negatives under them are called complex numbers. We're not really responsible for those in this course, so you can get away with just telling me that there's no x-intercepts and there's no real roots. And all of this can be told from the discriminant. So once again, your discriminant, discriminant, sure, whatever, is equal to -b. No, it's not. Your discriminant is b squared minus 4ac, just that value. You don't need the square root sign. It's just this value that I'm interested in. If your discriminant is greater than 0, you're going to have a quadratic that has two x-intercepts. If your discriminant is equal to 0, you're going to get a quadratic that has one x-intercept. And if you have a quadratic that has a discriminant that's less than 0, negative, you're going to get no x-intercepts. It's not going to cross anywhere. This one will be two real roots. This one will be this is two real distinct roots or different roots. This is two identical roots. I'll explain that in a minute. This is two complex roots or no real roots. This is two x-intercepts. This is one x-intercept. This is no x-intercepts. So once again, two distinct or different real roots, two x-intercepts. This is two identical real roots and one x-intercept. The word identical here is what makes it the one. The distinct is what gives you the two different ones. And this is no real roots, and that's good enough for us. There are two complex roots, but we don't need that. And there are no x-intercepts. Okay, we'll stop there, and I will be back in a minute.